Now we are going to talk about parallel line and perpendicular line, right? Parallel line and perpendicular line. Okay, so you know, parallel line, when we say two lines are parallel, they go like this. Well, that's hopelessly doesn't look parallel, but let's pretend that these two lines are parallel to each other. Let's say this is line number 1, this is line number 2. I mean, to be precise, parallel line is just a concept. They don't exist. I mean, can you think of any two parallel line? I mean, if you draw a parallel line, if you extend it infinitely, I'm sure they'll cross each other at one point because they are not parallel. Because it's almost impossible to draw a two parallel line, right? Perfectly parallel. It's almost a conceptual thing. Anyway, so when we have these two parallel line, let's say the slope from this first line is m1. Let's say slope from the second line is m2. If they are parallel to each other, what should be the relation between m1 and m2? If they're parallel to each other, well, m1 and m2 must be equal, right? That's what they mean by parallel line. Okay, what about perpendicular line? Perpendicular. So perpendicular line, one line goes like that, another one line goes like this. Wow, really not straight. Oh, it's not that much better, but let's pretend that these two are two straight lines. Right? So this is L1, this is L2. Perpendicular line means they are crossing each other at right angle, 90-degree angle. So let's say we have M1, the slope 1 from the first line, and say M2, slope 2 from the second line. What should be the relation between M1 and M2? Well, M1 and M2, they should be negative reciprocal to each other, right? Whatever that means, right? Negative reciprocal to each other. Meaning, if you flip one of them and put the negative in front, then it should be same as the other. Or on the other hand, on the other word, you can say m1 times m2 must be negative 1. m1 times m2 must be negative 1. So example, let's say m1 is 2/3. If they're perpendicular to each other, what should be m2? m2 should be, you flip the first one, which is 3/2, and you put the negative in front, like that, right? So, and these two are perpendicular to each other. Another one, let's say m1 is negative, say 1/5. What should be m2? Well, you flip this, which is 5, right? 5/1 or 5, and you put one more negative because it should already negative, but when you flip, then you should put negative anyway. So negative negative cancel to be positive, so it's just +5. And you can also check by multiplying these two numbers, see if it becomes -1, and it does. So these two are perpendicular to each other, and these two are perpendicular to each other. So let's try this example. So examples. Find an equation of the line that contains, say, 1, -2 and a parallel to x plus 3y equals 6. Right. So line equation that we tried to figure out, it's passing this point, and we need a slope, but we don't have slope, but we have another clue. Line that we are looking for should be parallel to this line. So we need to find a slope from here. How do we find slope from here? We need to convert that into slope-intercept form. If we convert that into a slope-intercept form, then we can easily find the slope. So slope-intercept form was what? 3y, move this x to the other side, -x plus 6, and divide everything by 3. Because we want the y and y only. Then this would be y equal, well, -1/3 x plus 2. So there we go. This is going to be our slope. So now we have m as 1/3. So we have this point and m. So when we have a point and a slope, what form should we use? We should use point slope form. So y minus y1, which is -2, right? This is x1, y1 equal m x minus x1. Oops. X1 should be 1. Okay. So let's simplify. This would be y double negative becomes plus -1/3 x minus 1. I mean, there is more than one way to do this, but if you want to put that into a slope-intercept form, you can also expand this just by multiplying. If the question didn't really say anything about what form that you should put it in, then you can choose your own form. You can put it in the general form. You can put it in the slope-intercept form. But let's try the slope-intercept form this time. So, y plus 2 equal -1/3 x, -1/3 times -1 plus 1/3. Now move this 2 to the other side. Let's do it in here. Y equal -1/3 x plus 1/3 -2. Okay, so how do we combine these two? We need what's called the common denominator, right? So y equal -1/3 x plus 1/3. We're looking at these two as 6/3, right? In other words, we're looking at this 2 as 2/1, multiply 3, top and the bottom, to have the common denominator 3. So our final answer would be, let me write the answer here, y equal -1/3 x. 3, 3, 1, -6, -5/3. So that's the final answer that we're looking for. Parallel to this line, passing this point, right? Okay, now let's try the second part, the B. Now A part was parallel to this line. Let's do perpendicular this time. Now line is perpendicular to x plus 3y equals 6. Now, from the previous case, we know that this equation changed to this, right? And y equal negative 1/3 x plus 2. We can change this to here. M is this. M is this. But we are not looking for same slope. We are looking for slope that perpendicular to this, which means we have to flip it and we're gonna put the negative. So when we put the negative reciprocal of this, it's going to be 3 that we are going to use, right? It's going to be 3 that instead of this, right? It's going to be 3. So 3, and the point that we are looking for is 1 and 2, this point. So when we have a point and a slope, again, we need to use the point slope form, which is y minus, well, let me just check. Yes, y negative 2, y1 equal m x minus x1, 1. All we need to do now is just simplify this. So y plus 2 equal 3x negative 3. So move that to here. Y equal 3x negative 5, right? This positive 2 becomes negative 2. Negative 3, negative 2 becomes negative 5. And this is our answer, right? All right.